Welcome back to the Infinite Jungle. On today's episode, I have with me co-founder of Anoma and Namada, Adrian Brink. Hi, Adrian. Thank you for being on the show.
Thank you for having me.
I am very excited to talk with you about intent-based architectures and the various projects that you are working on via Anoma and Namada. But before we get started with the show, here is a quick show disclaimer for our listeners. I need to remind you to please refer to the disclaimer linked in the podcast show notes and note that none of the information in this podcast constitutes investment advice, an offer, recommendation, or solicitation by Galaxy Digital or any of its affiliates to buy or sell any securities. So, Adrian, I have been reading up on intents, and the way that I understand it so far is that intents are primarily a UX improvement for crypto. Instead of defining how a user sends like a certain operation on chain, which is limited to kind of the operations that you can do depending on the chain you're on, you simply share what the result of the transaction that you'd like. So instead of defining how you execute your action, you define the end result of that action, and you allow a different network of actors, solvers, to go ahead and get you the end result that you want. This is how I understand intents. It's helpful for users that don't want to get into the nitty-gritty of blockchains. It's generalizable across different chains as we head to more like a cross-chain future. You gave me a couple of faces. Tell me what you're doing. Where am I missing? What am I missing?
I think all of that is correct. Intents definitely lead to a improved UX for users because they much more cleanly represent what users actually have, right? When you think of what a transaction is a fully fledged state transition that you run against some specific state on chain. So you update the global database. That works really well if you know exactly what you want. However, most people just don't. I mean, historically, like in Bitcoin, you went to a store, you got some milk, you paid some Bitcoin. You knew exactly what you wanted. In the more modern times nowadays, most users don't have this kind of very specific update. They all have like, I'd like to sell some ETH for Bitcoin. I don't actually know with whom or whether one party, 2 parties, 50 parties, whether there's an AMM involved, whether there's multiple chains involved, right? And so in that sense, intents are much cleaner abstraction for end users in terms of expressing what they actually have, because they actually map exactly like users have partial state transitions. They don't have fully fledged things that can update the global state. But I would not say that it's just a UX improvement. It's a fundamental improvement on the underlying architecture that allows us, for example, to have way more scalable systems, that allows us to have privacy-preserving systems, that allows us to have actual decentralized order book exchanges, as one example. It also enables things like composability on a chain level, right? Like when you currently think if a user sends a transaction, that transaction isn't really composable with other transactions. If I have an intent for application A and an intent for application B, those two things can be composed, because as long as like the state updates don't conflict, since none of these intents committed to a specific compute path, I can now start composing them. So like I can compose across 50 different intents across 10 different applications. This even gets better in the cross-chain world, where all of a sudden I can compose, like I can say, well, I'd like to trade A for B just on any of these 3 systems, just give me the state update. Just like execute this wherever is fastest, for example. And I think the last thing is intents also mostly solve MEV, because with intents you specify a specific state outcome. Of course, if you specify a wrong state outcome, like a shitty limit order, for example, you will get filtered that. But sort of very conceptually speaking, you specify a specific state update that you're willing to see, that you want to see. Like there's no way to front run this, because like I've specified exactly what I want to get as an outcome. One of the big problems right now in like the MEV landscape is that like, you specify more of a computational trace, and then I can reorder them. And depending on how you interleave the computational traces, as in normal transactions, you get very different outcomes that people may have not expected. So I think, yes, intents help with the UX, and they make UX way better for end users, but they're also just a very novel concept for underlying architectures. And like the more architectures can adopt this, the more scalable, the more decentralized they can actually become. Because like one of the simplest things to think about, like when people think about rollups, it's just intents. Because what is a rollup? It's like intent A to B, another one B to C, and the rollup provider just collapses this into like A to C.
Right, by batching transactions. I mean, when you say it's changing the architecture, it's really like an architecture shift. None of the underlying architecture, though, really changes. It's kind of like the intent interface just sits. It's like this general kind of interface that sits on top of this Ethereum blockchain or Cosmos blockchain and changes kind of the way in which users define what they want to get done on chain. Is that correct?
Yeah, that's exactly true. So the easiest way to actually think what Anoma does, and as far as I'm aware, and I'm fairly deep into the matter, it's like Anoma is the first and only so far generalized intent system. And like the easiest way to think of this is it's a distributed operating system for decentralized applications. Anoma does not replace the EVM or Ethereum. Anoma is fundamentally it's an intent machine that you deploy on top of Ethereum in order to get generalized intents for Ethereum. And over time, you can also deploy Anoma to many other systems. You can deploy this to Optimism, to Arbitrum, you name it. And at that point, Anoma forms just this distributed operating system where you have the same operating system APIs that developers and users can start relying on and start working against. But the specific settlement guarantees and the specific sort of trust assumptions of where that settlement happens, that is honestly at that point, it's a user choice. Does the user want to be on Optimism? Does the user want to be on Ethereum main chain? So yeah, I would really think like kind of, I always like to use the analogy where like Ethereum didn't replace Bitcoin. It honestly just made it better. Anoma doesn't, in my opinion, like I think like there's like they're not replacements for each other, right? And in that sense, like Anoma is not a replacement for Ethereum. It's like it's not trying to compete with any of the existing sort of settlement layers. It's just there to offer better abstractions to developers and users wherever they may want to run those abstractions. Kind of like what Windows 95 did, where you could deploy Windows against an ARM chip, against an Intel chip, and like you didn't have to rewrite the applications because once they worked against Windows, those applications worked wherever Windows ran, no matter what specific CPU you had under the hood.
So Anoma, I've been hearing about Anoma for a while. How close is Anoma to having this interface up and running, ready to go? I am under the impression that there's been a lot of talk about what Intents could enable. I'm curious to know, just how far along we are in this development journey, Adrian.
Yeah, so depending on when this podcast comes out, which I actually don't know exactly, you may be able to play with the code. Depending exactly on the timing. So
As
everything.
in, the user could generate an intent and see how it
Yeah,
could play
it
out.
first starts with developers, right? So developers can start playing with the platform. We'll have private devnets this year, public testnets early next year, and then targeting mainnet towards middle of next year.
Okay.
So it's coming. I should say, Anoma innovates at. So one of the maybe challenges with Anoma is Anoma does many things. Like Anoma tries to be or is a very complete solution to a number of different problems, ranging sort of from heterogeneous trust to abstractions for application developers with intents to privacy-preserving capabilities that sort of where we don't have to build this extra stack on top in order to get privacy-preserving applications going. So it's a very complete solution. As a result, it's kind of difficult to understand, and the rollout will happen in phases. But it's getting there, yeah.
That's very exciting. And is the initial vision in terms of the rollout, because there are many pieces that need to come together, different actors, which I hope we'll have time on this show to talk about, to support this new kind of way to execute transactions. Will Anoma in its initial phases be rolled out as a generalized intent interface on top of Ethereum?
Yes.
That's going to be the first
Yeah.
mainnet of
So
its.
the important thing to understand with Anoma is like Anoma is like when people think of sort of like large scale infrastructure projects, they always think like, oh, there must be a chain that I must interact with. And I want to make this very clear. There's no Anoma chain that you must send your intent to. This would make no sense. Like if you have a central thing that you all must interact with and then does the abstraction for you, great. You've achieved nothing because you just added another like failure point in the middle of your system. And like Polkadot tried this, Shared Security tried this, Cosmos tried this. Like the central point in the middle never really works out. So Anoma is really like there's no Anoma chain. Anoma runs where you want it to run, starting with Ethereum.
Starting with the integration with Ethereum, and then it'll integrate hopefully with other chains.
Yes, I mean, to be fair, if you realistic look at this, where's most of the value at the moment, this is where like Anoma should go first. There are a couple of optimizations we can be making here with an Anoma L1 over time. But think of it as more like not as competing with existing L1s. It's more like it's a more optimized implementation of the CPU effectively to run the operating system. It is not like if a user never wants to touch a global L1, they don't have to. And this also comes from my very strong belief that like the reason why this space exists is to build World War III resilient infrastructure. And so like the goal is that your local community, like your 5 friends, can run an Anoma instance to do local settlement that's still composable with the global system. Because I'm not convinced that like all these decentralized systems will do all that well when global fiber goes away.
I mean, you would think that that is the intent of this space. However, the trends of the crypto industry show that we are trending more towards centralization rather than away from it. I think the rise of Solana, the pivot to the roll-up centric roadmap on Ethereum all shows that decentralization perhaps is not the be all and end all of what crypto is supposed to be. However, I will say, as you've talked about this roadmap for Anoma and seeing the intent vision come alive, starting with the integrations with Ethereum, I'm curious to know how the timeline for this other blockchain, the L1 blockchain, Namada, comes into play, the privacy chain. How does Namada fit into this project? Are they completely separate? I'm under the impression that there are some synergies between the two. There's been some developments on the Namada side as well. Can you explain a little bit about the crossover there?
Yeah, absolutely. So the way to think of Namada, I mean, Namada is really, it's a bunch of crazy folks within in the Anoma community, within the Anoma ecosystem that deeply care about privacy guarantees and that want to try them out much sooner and in sort of a much more specific way than what you can do with general Anoma. They're not competing. It's just like one of the sort of things in the Anoma ecosystem that leverages some of the technology and over time can also start upgrading and integrating more of sort of the consensus stack behind Anoma. But honestly, that's like yet to be seen. It certainly can be one of the controller instances. If users want to settle some state, eventually Namada can also run an Anoma protocol adapter. Since Namada is just one again. The rollout here is crazy, actually. I mean, I actually don't know. I mean, like before the beginning of the show, we talked about sort of like when mainnet for Namada. It's like, I think pretty soon. The validators seem to be doing things. I've read a forum post 3 or 4 days ago that Genesis transaction submissions coming to a close. I think end of in 7 days, next Friday. And then it's really up to the validator community to decide when they want to stand up the network. I think the initial discussions there probably take 2 or 3 weeks to test out the software with a specific mainnet configuration. So depending on how the validators do, sometime end of October, I guess.
And how is it that privacy is preserved using intents on Namada? What's like the kind of killer, the key feature there, the innovation there?
So Namada doesn't have intents. Namada is a very simple, very straightforward system. You can think of it more like proof of stake Zcash, but multi-asset with IBC enabled, so you have true interoperability with fast finality, with all those kind of belts and whistles. So it's like one of the first times you can actually get good data protection guarantees, not only for financial assets, but generally like for any asset that you want, for any data that you want, really. It's kind of strange how we start ascribing financial meaning to all these bits and bytes floating around on the internet. So like whatever you want to put into Namada to get some amount of data protection for, you can. And so Namada doesn't use intents. This is really something that intents are something that come with Anoma. where Anoma really does this innovation, like what is the fundamental architecture that we're talking about here. And I think a lot of people forget this, though, also with, if you want to have true sort of multi-party compute, as in you want to have the ability to do things with other people. Like one answer is to have some amount of global state. This is like the answer that we all take right now with Ethereum. We have a bunch of globally transparent state. As soon as you want to have privacy-preserving interactive applications, you need fundamentally intents. Because by wanting to make them privacy-preserving, you push state to the edges of the network, so like to edge devices. And what are intents, really? Intents are the ability to like make partial state updates, partial state transition functions that you can like have in zero knowledge, and like prove zero knowledge in zero knowledge over. And so without intents, you can't really have interactive privacy-preserving applications. And so I think it's coming together very nicely, where like in the long run, we fundamentally need intents not only for application composability, for like settlement composability, but also for like privacy-preserving applications that want to have interactivity. I think there's actually no way around getting some amount of intent infrastructure into every existing system.
Right. Okay. So to confirm, the crossover and the connection is that in the Anoma community, in the people that are excited about this intent project, there is a group of developers that are very focused on creating privacy preserving crypto technology, and they are starting an L1, of which you are also a part of, building this new L1 that it has a new spin on privacy preserving transactions where you can swap over assets like ETH or Cosmos, I don't know, Atom or something like that. And then once the intent machine goes live for Anoma, obviously Anoma could integrate with that chain, but also many others, to confirm. I see. Okay, that is clear. Well, one of the other things that I wanted to talk about in as we're talking about Anoma and talking about this project, is some of the key actors, the key players outside of just the users and the apps that are going to be necessary to realize this like intent future. Can you talk to me a little bit about who the most important actors are in an intent-based system? We kind of mentioned earlier on in the show the role of solvers, and there's of course very lots of discussions around kind of the specialized actors that are needed, that have been created with an MEV system, and there's concerns about the centralizing effects of, say, the builder ecosystem, the relays. Tell me about, do those same problems exist with an intent-based architecture? What are the key actors involved, and are there centralizing effects there that you're concerned about?
Yeah, let me maybe start off with a quick overview of the different actors. So it all starts with users. Users have to define some intent. Those intents are partial state updates that are conditionally settable somewhere. And really, like intents, the way to think of it, intents allow users to specify, to outsource compute, bandwidth, or storage to specialized actors across the network. This is like not something specific to, for example, asset trading. Is just like, as a user, I can outsource compute, for example. Like, and maybe my computers find me the best route to trade my assets from A to B, right? And so users issue these intents. They say, like, I currently have state A and I'd like to have state B. State A may live on chain 1. State B may want to be received on chain 2. Those users then send it to a sparsely connected P2P gossip network. And really, don't think of this as a consensus P2P network, but rather like you can define who you want to talk to yourself. Not everyone has to be globally connected. There's no global gossip, no global broadcast. Those intents then sort of get gossiped around, and eventually they reach solvers. Solvers then do actually the hard compute and get paid for it. It's actually a very clean abstraction where it's like users attach fees to their intents. If it's a simple intent, they have to attach a very small fee for a solver to like be willing to do the compute in order to solve it. If it's a very complicated intent, like get me a rare flower from the rainforest, it's maybe a much higher fee, right? Like you can think of it this way. So then solvers figure out the compute. They, for example, maybe generate a bunch of zero knowledge proofs that was what was required, or they like figure out some other like inverse to like ETH BTC, BTC ETH. Then solvers wrap those things in transactions and then submit those transactions to wherever those intents wanted to be settled in the first place. So this may very well be the Ethereum main chain, this may very well be a global Anoma one, this may very well be Solana. It really depends on where the users want to be, or this may be an L2, right? Like this is really up to what the users want. And maybe the other really important thing to understand here is Anoma is very topology agnostic. As in, many of these networks currently are designed with specific topologies in mind. Anoma, like we never thought we were confident enough to make the choice on like what the actual topology of the network was going to look like. So we structured Anoma to sort of be configurable to the actual economics of the system. If there's only going to be a single chain, great, fine. That can happen, that's fine. Anoma still works wonderfully well in that case. If there are going to be hundreds of thousands of chains, Anoma works also equally well. If there's going to be a bunch of local chains, same thing. Anoma is very topology agnostic in that sense. With regards, so really like whether users want to be centralized or not, like whether the system ends up being centralized or not, is really a question of user behavior. If we all use the same single server as our like settlement layer, the system is going to be centralized. And there's nothing I can do as a protocol designer to like fix this, because like I'm not going to change 7 billion people's like fundamental behavior. I think there's strong arguments that most people will want independent settlement zones, and Anoma makes this really, really easy. This is sort of like the big thing. I think a lot of our existing infrastructure was not designed with being topology agnostic in mind. And as a result, there's sort of architectural centralization points. Those don't really exist in Anoma. So for example, Anoma comes with one thing, like you get composable solving, which is very important to help with solver decentralization. As an example, Christine, if you have an intent that goes from A to B and I have one that goes from B to C, that's not settleable anywhere. If we happen to send it to the same solver though, that solver can collapse into A to C. So the solver does partial compute and then reissues a new intent from A to C. So we don't have to rely on this mega solver. This is what everyone in sort of the rollup centric world now starts talking about, like let's have these mega solvers to make everything very composable. It's like, well, or we could like actually do the hard work and like thinking about composable solving. And once you get composable solving, we don't have to rely on having a single large solver to do all the work for us. So this is like one aspect. And the other aspect is by having a well-defined P2P stack that connects a lot of these systems together, it becomes very easy for users to do runtime configuration to switch the specific topology. Like one of the big, and you mentioned this with the relays, one of the big problems is that they're kind of enshrined. It is very difficult for users to like opt out of the system and like to pick a different relay. In Anoma, you can just express this in code as you write your intent that like, I'm not willing to be settled by this relay. Anyone but this relay. And so like as a user, you can have much higher levels of influence over like what specific topology you end up with. Because you can like kind of think of it like as a user, you get a higher level of abstraction, but at the same time you get lower level access to a lot of the underlying primitives so that you can express your actual preferences much more granularly.
And given that so much of this innovation in terms of the kinds of actions that you can generate and the types of entities, like what a solver will have to do is pretty new, in terms of how you're thinking about the cost, like how to price these intents and what is enough to incentivize these solvers to do certain types of work, are you envisioning like kind of almost like see if this incentivizes a network of solvers and then maybe up the cost or lower the cost depending on how it turns? Like how are you guys thinking about the pricing mechanisms and the incentive mechanisms to really make sure that this is sustainable?
Yeah, again, we've maybe taken the very principled approach of being very general here. Anoma does not really define basic fees. Like if an intent wants to be issued with 0 fees, you can. If a solver is sort of like willing to still do the compute, do the work in order to solve that intent, Good for you. You got like a bunch of free compute. If, for example, you have a very simple intent, let's say it's like super liquid pair, you want to trade, you have ETH and you want Bitcoin, yeah, that's easy to settle. That's going to be like minimal fees, effectively to incentivize the solver to like pick up that flow. If you want to do something very complicated, you may have to attach more fees. But this is not really this is very flexible at runtime depending on the actual compute that you want to do. The super nice thing, since this is kind of the problem with transactions, and we're starting to see this emergence of these overlay networks that like sit outside of Ethereum core gossip and core consensus, which is I don't have to gossip my intent to everyone in the world. And as a solver, I don't have to receive everyone's intent. So as a solver, for example, I can stake some tokens to say, well, a user can stake some tokens to me, and as a result, the solver promises them some like basic level of compute every month, called that way. But it's more that and if a user then ends up like spamming that solver, the solver can just go like, no, I don't like you anymore, and like I'll cut off your connection. I'll just like drop you on the TCP stack, and just drop you at the low-level networking stack. So it's very flexible. It's like not all solvers have to see all intents. So like if I'm, for example, in Switzerland at the moment, there's a latency advantage here. Like if I can find a Swiss solver, I just send my intent to the Swiss solver. If I then travel to New York, I can send it only to the New York solver. So like we don't have to flood the global network. As a result, we can have relatively low fees and also super low latency. This is actually, I think, I talk about this as World of Three resilience, but the other thing is like latency games matter, and nothing will be faster than Anoma. Like Solana cannot be faster than a local Anoma instance. If three of us are in a room together and we run a local Anoma instance to do local solving and local settlement, no amount of global consensus is going to be faster than like us going over direct P2P fiber connection with each other over the next over 1 meter connection, right? And so as a result, you can sort of structure the network really really flexibly, where if you have lots of economic activity that's happening next to each other in New York, you can have a New York sort of P2P overlay where most of the gossip is happening in New York. If you want to have some global or some World of Warcraft things, you can structure the network that way as well. So as a result, the other important thing with intents, intents don't cost fees in the sense of general gossip. So if your solver is just willing to accept fees, as a user, I only pay fees if my intent gets settled, which means I can send a new intent every second with a new updated price point, and that's just works. I don't have to pay for every intent that I send.
Interesting. And I guess a lot of it would also be dependent on the fees and the activity that's happening on the underlying chains, right? Like if I have an intent that wants to execute a certain trade on Ethereum and it just so happens to be at the same time that an airdrop is happening on Ethereum, that
Yeah.
calculation is.
It always depends on state locality. Like if you want to access or be synchronous with a bunch of highly contested state, it's going to be more expensive to access that state. The thing though is, with Anoma and the operating system architecture and the state layout of Anoma, it is much easier to sort of move state between different instances so that most people don't really need to be synchronous with it makes no sense that my payment transaction for food in Switzerland is synchronous with your payment transaction for food in New York, right? This makes no sense. We have this because we don't have an architecture that sort of very flexibly allows us to move state between different instances. Anoma kind of solves this by trying to rethink the state layout. And so as a result, I think overall the systems will just become cheaper because individual users can pick much more granularly where that state is supposed to live.
Well, this has been fascinating. And honestly, all of this flexibility, the extent to which it's agnostic and you can kind of plug and play so many different aspects of it, make it so difficult truly to grasp. I will let you know, Adrian.
Yeah, no,
So
I'm
I'm gonna
aware.
I'm going to have to see really how this does get used. And actually, well, as a very final question, because we are out of time, you had mentioned that in the Anoma community, based on all of these conversations, there is this one group that's actually building an L1 privacy blockchain. Are there groups that are already kind of have a very specific like wallet or very specific kind of like use case that they are already building for when Anoma goes live? Because maybe that, will
There's a
help.
couple. I mean, again, depending on when this comes out, there may be an announcement around builders. So if it hasn't come out yet, you've heard it here first. There may be an announcement around like a program there. But yeah, there are a couple of applications that a number of people and teams are really excited about. I think the one that I'm really excited about is a privacy-preserving order book exchange. That's like actually truly decentralized, where people can like pick their own gossip networks. You can privately trade. You can decide who you are willing to reveal what information to, and you don't have to split the liquidity. So you can settle transparent intents as well as private intents together at the same time. So like in the end, it becomes a user choice whether they want to trade privately or not. And like it's not different from them trading transparently. So like you don't have to split the two user bases apart, which I think is quite important in terms of liquidity. That's I think some of the examples that I'm really excited about. There's also a lot of work around scale-free money and new economics. Sort of like, is it a really good idea to have a single global base currency? Or should we better represent actual economic flows by having localized currencies that represent local economies? So there's a lot of background work at the moment in terms of actually doing underlying research. Because for better or for worse, I think when we started Anoma, we sort of realized that not a lot of people like wanted to spend a lot of hard time like actually trying to understand the systems. Everyone was like, let's copy these three contracts to the next thing, and like for some like this to us never felt like we're going to make progress as an industry doing this. So we've always come up with this very like, let's think about the problem first and like figure out how do we actually design these systems around that.
Yeah, when you were talking about some of those applications, it got me thinking, about kind of the compliance angle of this as well, and how
This is
some of
super nice actually as a result, because you can define whether you are willing to settle with people on this blacklist or only people on this whitelist or not in those assets. So you have this super granularly control over who your counterparties are, which is super important because if I'm in Switzerland, I need to respect my local jurisdiction. And so I can very granularly define what my local jurisdiction requires, which is why I'm actually very excited about this.
Right. But you are executing it through the solver, and in which case the solver itself has the ability to kind of use whatever means that they have access
No,
to
that's the thing. So my intent can say I'm willing to like exchange A for B only with people on this whitelist, or like only people not on this OFAC list. And then solvers have to figure out how to source something, an intent that satisfies my requirements. So for example, if I'm issuing an intent that says my intent can only be settled against an intent that was issued by Christine, the solver would have to say, correct, go to you and get your intent and settle this. And of course, it means that if I make my intent too specific, it will never get solved and will never get settled. But that's fine.
Right. But the burden then is on solvers. And it's similar to how no user sets the requirement, but the OFAC compliance comes from the relays and the builders themselves. I mean, it would be the solvers kind of the burden, I guess, kind of shifts to solvers then in this situation.
Not exactly. I mean, like the user would define what specific sanctions they want to adhere to. And the solver, so like, for example, I can say, I would like to trade ETH for Bitcoin, but only if the Bitcoin comes from those 5 addresses. And then if I get Bitcoin that comes from any other 5 addresses, it's like not settleable against my intent. And so as a result, I can, like, as a user, enforce my own sanctions effectively, which I think is a smart idea, because what I essentially want in the end also, it's not actually about sanctions, but like, I just don't like to fund a bunch of things. So like, I may not like anyone that like sells weapons to people. And so like, I'm just blacklisting people because I don't like agree with their business morals. And yeah,
Yeah.
but like solvers will have to source intents that are compatible, and that may not happen. And like in that case, I have to relax my requirements, or I just become my intents don't suffer.
Right, right. I mean, I have a hard time seeing that users would be the ones that are setting those kind of
Essentially,
parameters.
it will be down to the front ends most likely.
Yeah, yeah. No, that's fair. I mean, this is fascinating just thinking about practically how this may, yeah, impact and how users will be able to play with it.
I have to say, I think as an industry, we kind of have to accept that we're going to live in this heterogeneous trust world because the world currently is heterogeneous trust. And so, like, for us to interface with it, we should accept that there will be many different requirements, and we should just be building infrastructure that is capable of living in this heterogeneous trust world because this is the best way that we can interface with the real world.
Yes, yes. No, 100%. I think the extent to which our technologies can support that, and with things like the intent interface, I am very keen on seeing how this all
Me
plays
too.
out because of how it's such a big vision. I mean, just the sheer flexibility of this system is really something that I am keen on seeing. You know, to what extent it really is able to be this flexible, and be this plug and play. So, thank you, Adrian, for going through some of the details of this and a very exciting project to talk about.
Thank you for having me, Christine.
And thank you to our listeners who was listening to this episode of the Infinite Jungle. We hope that you learned something new about Ethereum, but also something specifically new about what could be coming to Ethereum um, in the next few months slash year. Um, and we hope that you'll join again for a new episode of the Infinite Jungle next week. In your explorations of the infinite jungle that is Ethereum, stay safe out there, everyone.